Hello everyone, welcome to this video. In this video, you're going to learn how to draw Bode plot and polar plot. First is the Bode plot. Bode plot has two parts. First, drawing the Bode plot and finding gain margin and phase margin, and also gain and phase crossover frequency. In part B, we're going to find the value of gain K for a specified phase margin and gain margin for the same system. Now coming into the part A. Before writing MATLAB code, first Bode plot has to be drawn using semilog graph sheet for the desired transfer function. Once you have drawn the Bode plot in the graph sheet, you have to be ready with the following theoretical values, that is gain margin, phase margin, gain crossover frequency and phase crossover frequency. It is to be done so that you can compare with the simulation result. Once you are done with these theoretical values, then jump to the MATLAB and write 4-line simple code. In this code, you notice the number 1320 for the denominator and the numerator 1. So these are nothing but the coefficient of the transfer function what you are taken. For example, in my case the numerator is 1 and the denominator becomes 1, 3, 2 and 0. 0 is to be written when there is no coefficient present. So once you are done with the writing of code, just execute the code. Save the program as Bode plot and run the program. Here you will notice the graph which has both magnitude and phase versus frequency. Here you will get to notice the values, that is gain margin. In my case it is 15.6 dB, phase margin 53.4 degree. So the frequency that is present at the bracket are nothing but the gain crossover frequency and phase crossover frequency. In order to understand very clearly, you zoom in the magnitude plot and mark a point which cuts the 0 dB line. That is the gain crossover frequency. In order to find phase crossover frequency, zoom in the phase versus frequency graph and make a point where it cuts the 180 degree, that is minus 180 degree line. So you'll get to know the 1.41 as a phase crossover frequency. So by rearranging the graph, you are done with the first part of the Bode. Once part A is completed, in part B, we have to find the gain K for a specified phase margin and the gain margin and verify the same using MATLAB. You can observe here my transfer function is 1 by s cube plus 3s square plus 2s. From this transfer function, I have obtained gain margin as 15.56 dB and phase margin as 53.41 degree. Specified value of gain margin and phase margin has to be given. Here, in my case, I have taken the specified value of gain margin as 17 dB and specified value of phase margin as 60 dB. For a specified gain margin, that is 17 dB, to calculate the value of K, we have a formula that is 10 power x minus y by 20, where x is the present gain margin and y is a specified gain margin. When you substitute these values in the formula, you will obtain the K value as 0.8475. Now, when you substitute this K value in the numerator and modifying the code in the numerator as 0.8475 and executing the code, you will obtain a plot wherein you will find the gain margin as 17 dB, which is exactly shifted from 15.563 dB to 17 dB. So from here you successfully obtained the K value as 0.8475. Next, the k value has to be found for a specified phase margin. Here, there is a little bit lengthy, but it's easy. In order to find this, first we need to find the frequency at which specified phase margin occurs. In a sense, my phase margin, that is specified phase margin, is 60°. So I need to find a frequency at which phase margin occurs. So to find the frequency at which specific phase margin occurs, go into the Bode plot which was plotted at the very first, that is without modifying the numerator, and click anywhere on the phase plot and drag the point till the phase degree shows 120°. That is 180 minus specified phase margin 60 gives 120°. So at this point, what is the frequency you obtain? You note down. In my case, it is 0.36 radians per second. Now click up any point on the magnitude plot and drag the point till the frequency shows 0.36 radians per second. Very slightly, so that the frequency in the magnitude and the phase plot matches. After matching 0.36 on the both sides, note down the magnitude in dB. Here I have obtained the magnitude as 2.17. That you need to substitute in the given x. So by substituting 10 power minus 2.7 by 20, you'll get the value of k as 0.7789. After getting the value, modify the numerator by substituting value, and when you run the code, so here you get a graph which has the phase margin 60°, which is exactly what we are required, that is specified phase margin as 60°. With this, the Bode plot is completed. Second plot in the same experiment is the polar plot. As same as the Bode plot, we have to have some theoretical values, so that can be obtained by plotting in the graph sheet and have the values like phase margin and gain margin. Once you have the theoretical values, type in the code in the MATLAB as shown in the notepad. Here the MATLAB code has already been typed by giving the transfer function, and when you run the program, you will obtain the graph as well as the values in the command window, where you can find all the frequencies like phase crossover frequency, then gain crossover frequency, and also get the magnitude, phase angle, and phase margin. Finally, at the end of this video, you got to know how to draw Bode and the polar in the MATLAB and compare with the theoretical value. As you can observe in the tabular column, both the Bode plot and the polar plot have been mentioned, and their respective theoretical values and simulation values are also mentioned. It is observed that simulation result is almost equal to the theoretical value, and in some cases they are exactly equal. So finally, it concludes that your Bode plot and the polar plot is correct. By this way, you can successfully complete the drawing of two plots, which is very important. Thank you guys. Thanks for watching.